Next up is Lee Fuller. I think many of you may know Lee. He's local Vice President for Government Relations at IPAA, and Lee's been around a long time. He has 32 years of experience in his town in the political arena. Worked a lot of time on the Hill. He also is from Pennsylvania, though I didn't realize this. Lisa went to Lehigh University, so we do have a strong Pennsylvania theme here. And I think Lee is also head of EID Energy in Depth, and that's the industry's effort to try to tell its side of the story in hydraulic fracturing. And so, Lee, would you take over, please?
Thank you, Skip. Appreciate the opportunity to be here. I'd like to spend a bit of time here talking a little bit about putting hydraulic fracturing in context, a little bit back to what we've just heard, and then talk about some of the issues that we've seen over the past several years that have perhaps created some of the extensive public attention fracturing process. We look at hydraulic fracturing and think of it as a mechanical process, but it's really both a mechanical process and a technical process. The mechanical process, fairly obvious from just listening to its name. We're taking hydraulic pressure, taking a water sand mixture, fracturing formations with it, and using that to allow gas or oil, depending upon what particular resource play you're in, to flow. The chemical part of the process has gotten much less attention in the past. I think there was a slide earlier that showed that about 99.5% of the fluid that we're dealing with in the fracturing process is water and sand. That other 0.5% are the chemicals. They do a variety of different things. The water that's used is water that's raw. I mean, it can have algal growth, it can have bacteria in it, so you have to treat it to make sure that when you put that water down in a formation, you're not putting something in there that's going to grow in the formation and cause problems with your wellbore when you're done. You also have to put some chemicals into some acids, for example, to make sure that you're keeping the wellbore clean, some anti-corrosion agents so that you're not destroying the pipe that's in the wellbore when you're in the process of fracturing. And then you have chemicals that are designed to try to keep the water and sand mixture together so that you can push it a mile or two underground and perhaps a half a mile to a mile horizontally all together. So you don't leave the sand at the bottom of the wellbore and just keep pushing water through. And then you put the fracturing process in play, you break the rock. Now what do you have to do? You have to leave the sand in but take the water out. So you have to change the chemical makeup, or at least the chemical properties of this mixture, to allow the water to come out and keep the sand in. So that's one place, but it's also why those chemicals have become an opportunistic way to try to, in some way or another, attack the fracturing process. As you've heard earlier, the Marcellus Shale, most of the shale formations that we have in this country tend to be 5,000 to 10,000 feet below the surface, a mile to 2 miles below the surface. Drinking water sources, groundwater sources, tend to be within the first 1,000 feet. So the question is, obviously, what's the pathway that this could allow any of these chemicals to get to the groundwater? And as you've also heard, essentially it's not going to be a pathway through the general geology of the area. It's going to be through the wellbore. So the key question then is, how's the wellbore regulated? George talked about this earlier, and we've heard about it previously as well. When you go through the groundwater part of a formation, you're required by the regulatory process to put in place additional casing or pipe and to cement it in place above and below so that a barrier is placed between the wellbore and the groundwater. Why is that done? How long has that been done? Well, in reality, that technology predates the 60 years of time that we've been using hydraulic fracturing. It goes back to the turn of the century or in the early 1900s. And why? Because at that point in time, you were worried about two things happening. You were either, when you had an oil well, you were worried about your oil winding on water instead of out the wellbore, or you were worried about water getting to your oil well and diluting it and having to treat or manage a whole bunch of water when you're producing it. So the states over a long time period have created programs that protect groundwater and protect wellbores by putting a barrier in and preventing movement in and out of that wellbore. That same technology then, hydraulic fracturing fluids that are used, the water, the sand, any of the small amount of chemicals are there, are also protected from groundwater. And so, as we pointed out, as George pointed out, there aren't instances of problems with hydraulic fracturing creating problems in groundwater. They haven't occurred. It's true in Pennsylvania. It's true across the country. It's a remarkable success story for the regulation of this technology. It's not done by the federal government. It's done by the states. So why do we have an issue here? With that history, why do we have an issue here? Why do we keep seeing people raising this perception that there's somehow a problem that we need to be worried about with hydraulic fracturing? Well, the answer really is to look beyond the fracturing process and look at the more fundamental question, which is producing American oil and American natural gas. There are efforts to try to suppress that production. There are groups that want to wean this country from fossil fuels, despite the fact that 85% of our energy comes from fossil energy. So if you can't make the argument that hydraulic fracturing risk isn't managed properly, because it is, then you have to look at something else. And that focus has been to move towards the question of chemicals, the chemicals that are used in the process. People don't understand chemicals. People in local communities don't understand chemicals. So if you can create an anxiety in that community over chemicals, you can suppress the development of the resource. If you look at this issue over chemical disclosure over time, it evolves almost serendipitously as a part of the debate. Some years ago, there was a court case that ruled that hydraulic fracturing should be under the Safe Drinking Water Act, that the definition of underground injection was so broad that it covered hydraulic fracturing. That was never the intent of Congress, no federal regulations under the Safe Drinking Water Act. But we engaged in a lengthy debate from the mid-1990s until 2005 over whether there should be regulation under the Safe Drinking Water Act of hydraulic fracturing. In the course of that debate, we started seeing the evolution of this chemical disclosure, chemical issue as a part of fracturing. It started initially with a bad environmental impact statement that was written by a federal agency where someone looked at the fracturing process and they observed that at that time diesel fuel was used as a part of the fracturing process. Diesel fuel was used primarily as a solvent for the chemicals so they dispersed better in the water. Small amounts of diesel were used. But the person who wrote the article didn't understand that diesel and gasoline were two different things, and since there was a huge debate over MTBE and gasoline, he assumed it was in diesel as well. And so he put out a report that said that fracturing could put MTBE in your drinking water. And that report was run around the Congress for about 3 years, despite the fact that it was totally erroneous. The second step in this process was a study that was done and finished in 2004 by the Environmental Protection Agency, which looked at the fracturing process in the context of coal bed methane development and whether or not it posed a risk to groundwater. When EPA did that study, they found that there were no problems. They found no cases of problems, but that really wasn't a good enough answer for part of the public policy community, so that as a result, EPA went back and it hypothesized a concern. It looked at the fact that some was used in the fracturing process and that diesel always contains within it a certain amount of benzene and toluene and xylene. And so EPA said, well, if we had a problem, if we'd found a problem, then our concern would be that the BTX that's in the diesel fuel might have gotten into the water. And that suddenly became a clarion call that we were now needing to deal with the concern about diesel in the fracturing fluids. No incidents, but just a suggestion that it might be a problem. So when Congress changed the Safe Drinking Water Act, it made clear that it didn't intend to cover hydraulic fracturing unless diesel was used. At the same time, what we saw happening was a realization that there were these other chemicals that were involved. And those chemicals had certain proprietary confidential business information surrounding them. So the fact that they couldn't be readily disclosed became a reason to suggest that there was a problem, that there needed to be disclosure in order to deal with this environmental problem. Again, no risk had been identified, no history of problems had been identified, but suddenly chemical disclosure became a hot button. And that focus has continued and grows as we sit here today. We've seen several states grappling with this process and coming up with different questions of disclosure. As producers, we tend to get the focal point on this because we're obviously the people that do the wells. And as producers, I think there's two things that are important to us as we go into this disclosure debate. First is a recognition that when we're going to talk about chemical disclosure, it needs to be in the full context. It needs to be understood as a part of that 0.5% and under what conditions it may or may not get into the environment. The second is there needs to be some recognition that as producers, we're dealing in a world where other people make judgments about what we can and can't disclose. Chemical companies manufacture the chemicals that are used by the service companies that are used in the fracturing process. They set the parameter on what they consider to be confidential business information. So as producers, we don't have the right to disclose things that somebody else protects as confidential business information. We can provide information on what we know, but we have to be very careful as we have this debate of understanding that other players are involved. This is a country that values intellectual property. It's a country that likes to protect the rights of its manufacturers, and that needs to be a part of the overall balance as we make judgments about what needs to be disclosed and how it should be disclosed. I should point out that, as I said earlier, a number of states have begun trying to grapple with this, and they've been doing it in different ways. But most recently, two groups that really represent the state regulatory agencies, the Interstate Oil and Gas Compact Commission and the Groundwater Protection Council, announced that they are going to be working together to try to deal with this issue. And they hope to roll out some proposals on how to develop a more extensive national program to deal with the chemical disclosure issue and put it in the context over the next several months. The other issue we've heard a lot about is the water question. And as industry, I just want to say that we recognize this is a critical concern, that water is an inherent part of our ability to develop shale formations around the country. Water issues differ around the country. I think one of the things that we've seen is that the sensitivity about water management is something that we have to grapple with. Industry has been in the process of revising its various management practices, not only on things like casing and cementing, but also on the water management. The American Petroleum Institute released a series of documents on that you can find if you go to their website. I think we've also started seeing that the industry is looking at alternatives that it didn't have to look at in the past. Historically, the management of our produced water has largely been done in Class II underground injection control wells under the Safe Drinking Water Act. A smaller portion has been discharged under the Clean Water Act discharge permitting system. But I think, as you heard earlier, those things become relatively complicated to do, and so we're starting to see a movement towards the idea of looking at ways to recycle water, which has the beneficial effect of reducing the amount that's needed at the outset, but also reducing the amount that has to be disposed of at the end. So with that, I'll thank you very much, and I'll wait for questions.